Good morning. Here you can see the topic, simple pendulum. This is the pendulum. This is the equilibrium position and this is the displaced position and this is the amplitude theta. So here in this lecture I am not going to show you the derivation of the formula T is equal to 2 pi into root over of L by G. Okay. Here we are not going to do this thing. T is equal to 2 pi into root over L by G, where L is the length of the pendulum. Okay. Where from the length is measured? From the center of the bob. This is spherical mass. This is called bob. Okay. So from this center up to this ceiling. Okay. Here this is pivot. And from there the thread or the spring is hanging. Okay. So from this point up to this is called the length of the pendulum, which is denoted by small l. This thing is known to you, this is pi, and this is g, which is acceleration due to gravity, and t is time period. For leftward motion and for the rightward motion, one leftward and one rightward complete motion, the time taken for that, okay, that is called time period of oscillation. So all these things are known to you. Question is, in the thumbnail you have seen that if length of the pendulum be 500 km, then what will happen? Answer is, if length of the pendulum be 500 km, okay, what is the radius of the earth? It is only 6,400 km. So 500 km, this is a large distance as compared to the radius of the earth. And for this long distance 500 km, okay, this is sufficiently long distance, acceleration due to gravity will not be same throughout this length 500 km. Okay, if the length is like 1 meter, 2 meter, half meter, etc., so throughout that length we can easily assume that acceleration due to gravity remains constant for that small length. In terms of meters, only 1 meter, 2 meter, 3 meter or half meter, etc. Okay, we can easily consider that throughout that length, acceleration due to gravity remains constant. But in case of 500 km, acceleration due to gravity does not remain constant. So the procedure which was used for the derivation of this formula, that procedure cannot be used, the same procedure cannot be used for that derivation where length of the pendulum is 500 km. That is one answer. Next is, in the derivation, if you notice carefully, then you will observe that the mass of the string or the thread was not taken into consideration for the derivation. That was assumed to be massless or weightless. I am talking about the mass of the string or the thread, is this one. Okay, that was considered weightless. But in case of 500 km, for that much of length, the weight of the string cannot be neglected. Okay, so that thing also you need to consider. So that will no longer remain simple pendulum. So there is no question of applying this formula for that type of pendulum. And actually that pendulum is not a simple pendulum in case of such a large length. Okay. So I wanted to answer to this question. What if the length of the pendulum be 500 km? And this is the answer. Okay. In my next video, I'll show you the derivation. Derivation is known to you. Okay. Okay. Anyway, so this formula has certain limitations, and you know that this angle theta, if angle theta is less than, if it is less than or equal to, if this angle theta is less than or equal to 4 degrees, then only this formula can be applied. Okay. You just try to recall that sin theta can be taken as theta. Sin theta was taken as theta. Sin theta is equal to theta. That was assumed for this derivation. But in case when theta exceeds the limit 4 degree, in that case sin theta cannot be written as theta. In that case you have to use de Moivre's theorem. Okay, according to de Moivre's theorem, sin theta is equal to theta minus theta cube by factorial 3 plus theta to the power 5 by factorial 5, etc. Okay, so that series you need to use, and in that case you won't get this formula if theta exceeds 4 degree. But if the maximum limit of theta remains within 4 degree, then sin theta can be written as theta, and in that case you will get this formula. So that means this formula has certain limitations. You should know the limitation. Okay, you should know limitation for anything. But whenever you are studying something, some law or formula, you must know the limitation of it. Okay. Okay, thank you for watching this video.